All right, folks, Bass Action is back in action here. We are going to extend our discussion of complex numbers, and we're going to get into a pretty crazy looking problem down at the bottom. All right, sample number 2, this one's going to go pretty fast. It says a polynomial of degree 5 has real coefficients, and it gives us the following zeros: -2, 3i, and 2 minus 4i. What are the remaining zeros? Well, we know that if it's a degree 5, there need to be 5 zeros. And what this wants to call our attention to is the fact that our complex numbers, our imaginary numbers, need to come in pairs. So if 3i is a 0, then we should also have -3i as a 0. And if 2 minus 4i is a 0, then we need its complex conjugate. So 2 plus 4i should also be a 0. So that's really all that question is asking for us to do. Now, the next problem, you're going to have 2 choices, and it truly doesn't matter which choice you choose. It just matters that you get comfortable with one of them. You will have the choice of doing long division or synthetic division, and each person will have a preference of which one they would like to do, and it doesn't make any difference to me which one you choose. All right, this question says, if 3i is a 0 of this polynomial function, find the remaining zeros. So based on what we did in example 2, what we know is that if 3i is a 0, then -3i is a 0 as well. So now, we have some choices of whether we want to find the remaining zeros using long division or synthetic. If we want to do long division, what we're going to do is we're going to take our 2 factors that we already know, x minus 3i and x plus 3i, and we're going to FOIL those together. And if we FOIL those together and we're comfortable with our complex numbers, what you'll get is x squared plus 9. So if we're taking the long division route, we're going to FOIL this out, get the x squared plus 9, and use x squared plus 9 as our divisor. So we'll have our x squared plus 9, and then we're going to do our long division with our 2x cubed plus 4x squared plus 18x plus 36. Now, I happen to like the long division in this case because I know that my remainder is going to be 0. So what I'm going to do is I'm going to just start my long division. My 2x cubed divided by my x squared is going to give me a 2x. Multiplying that out, I get my 2x cubed plus my 18x. I'm going to line this up, and I'm going to fill in a 0x squared here. Now, I'm going to subtract. So I know that all these need to be subtracted, so I can change these signs and add. So those are going to cancel. And I'm going to get a 4x squared plus a 36. I'm going to do 4x squared divided by x squared. That's going to give me a plus 4. So I get 4x squared plus 36. When I subtract these, everything cancels out, and we get that remainder of 0 just like we wanted. So this problem then can be written as my x squared plus my 9 and my 2x plus 4. Okay, so I'm going to pause there, and we'll go over and we'll look at what would you do if you wanted to do this with synthetic. So if you were doing the same problem with synthetic division, you would have to do synthetic division twice. So we're going to start with our coefficients. So my coefficients are 2, 4, 18, and 36. And I can do my synthetic division with my 3i first. So I have my 2, and then I have a 6i, and then this becomes 4 plus 6i. I'm going to multiply that by the 3i, so that's going to give me a 12i. And then our 3i times our 6i is 18i squared, which then we're going to flip it to a -18. Now when I add straight down, the 18s will cancel out, and I get the 12i. 3i times 12i is going to give me 36i squared. That, of course, we know is going to cancel out to a negative 36. So we get our 0. Now, I know I'm not done because I can't leave this with these i's here in the denominator. So, or not in the denominator, I meant to say in the reduced polynomial here. I can't leave those i's there. So I'm going to do my synthetic division again with the other known 0 of negative 3i. So continuing that, I get my 2, and I get a negative 6i. Adding straight down, I get a 4. I get a negative 12i, and I get my 0. So I get all the zeros I wanted. So when I write this out, I would have my x minus 3i, my x plus 3i, my 2x plus 4, and then of course these are going to FOIL, and we're going to do what we started with on the other technique, and we'll end up with an x squared plus a 9 and our 2x plus our 4. So you can see that we're going to get the same answer no matter which technique we use. So I don't care which one you do, but you do want to decide which one you feel most comfortable with. Now, if I want to find the remaining zeros, I can take this polynomial and I can set it equal to 0. So I'm going to say x squared plus 9, and I'm going to say 2x plus 4 equals 0. Some people like to factor the 2 out of this piece. You don't have to, but you could write this same problem like this if it pleases you. Either way, we can see that this gives us our zeros, as we already found, of plus or minus 3i, and our last 0 is a negative 2. Okay, so that's a pretty common problem that you're going to run into, so you definitely want to feel comfortable with that. Now, this last problem we're going to do requires some very intense algebra, so I'm going to prompt you to pause the video, try to do some expansion, and then check your answers as we go so that you're not just watching me do all of this algebra. So first thing that we need to do is identify the quote-unquote missing zeros. So remember, each of our imaginaries need to come in pairs. So if I is one of my zeros, then negative I, then so is positive I. And if 2 plus I is a 0, then so is 2 minus I. Now, first thing we're going to do is we're going to write this out in its factored form. My 0 of 3 has a multiplicity of 2, so that's going to be expressed as x minus 3 and x minus 3. The next thing I'm going to do is I'm going to write my i's as factors. So x minus an I and x plus an I. Then when I go to write this next one in its factored form, some parentheses are going to be important for me here. I'm going to say x minus, and then I'm going to put the factor in parentheses, and I'm going to say 2 plus I. And when I go to write the next one, I'm going to say x minus, and I'm going to put its factor, 2 minus I. Now there's a temptation here to distribute this negative, but I'm going to tell you don't do that, okay? Now, what we're going to do is we're going to start doing some foiling, and I'm going to prompt you. I'm going to tell you which ones I want you to FOIL, and then I'll have you check. So I'm going to want you to FOIL these two. I want you to FOIL these two, and I want you to FOIL these two. So pause the video, FOIL those, and then see if you get the same things that I do. Okay, let's take a look. So when I FOILed these first two, I got an x squared, a 6x, and a 9. When I FOILed these two, my middle terms, because they're complex conjugates, were going to drop out. My negative I squared became my plus 1. Now, when I FOILed these two, I had my x squared. Then I had my x times my 2 plus I, so there's my minus. And then I have my x and my 2 minus I, that gives me this portion. and then my negative times negative gave me my positive, and I still left these as the two binomials. Now in the next step, what I want you to do is I want you to distribute your x's, your negative x's, and I want you to FOIL this remaining portion. So pause the video, do that step, and let's check our answers. Okay, so when I FOILed these out, I now have my negative 2x, my negative xi, a negative 2x, a positive xi, and when I FOILed these two, recognizing their complex conjugates, the middle term drops out, and I'm left with the I squared. So now from here, a couple things that I can do. I can see that my negative xi is going to cancel with my positive xi, and I can see that my negative I squared could actually become a positive 1. So this polynomial here can become x squared minus 4x plus 5. Then I can pull down my other polynomials from up above, and I can fill those in. So I'd have my x squared plus my 1, and I'd have my x squared plus my 6x plus my 9, and I can say this entire thing equals my f of x function. So there is a lot of very tedious algebra on this, but it's doable if you just take your time.